Hello dear viewers, welcome to another video tutorial of this YouTube channel. In today's tutorial, we're going to be focusing on question number 11, which is coming from the ECZ examination for school certificate ordinary level additional mathematics paper 2. So it is coming from paper 2, and the question that we're interested in today's tutorial, it is question number 11, which is falling under calculus. So it is falling under calculus. So let's now try to check where the question is located in this paper. So this paper was for the 2024 internal candidates. So let's try to check where the question is located. This is question number 11. Okay, so this is the page that contains question number 11. So this is the question that we're interested in today's tutorial. So the question has two parts. It has part A and part B. So part A carries 7 marks in total, and then part B carries 3 marks in total. So in total, question number 11 carries 10 marks. So this is the question. Let's try to go through each and every part of this question. We have part A. Part A says that the equation of a curve is y is equal to 2x cubed minus 3x power 2 minus 12x plus 30. So we have Roman numeral 1, which is stating that find the coordinates of the stationary points, and then we also have Roman numeral 2, which is saying that determine the nature of the stationary points. And then we also have another part of this question, which is part B. Part B states that given that y is equal to x squared e to the negative x, find the gradient of the curve at a point where x is equal to 1. So that is question number 11. So now let's quickly get into the solving. Okay, so before we get into the solving, I would like to remind you something. You need to subscribe to this YouTube channel so that you are always updated with the latest information on this YouTube channel. Don't forget to share so that others can also enjoy the tutorials of additional mathematics. Don't forget to comment so that we can hear out your views, and don't forget to also like this video by giving it a thumbs up. Let's now quickly get into the solving, and as you're subscribing, don't forget to turn on the notification button so that you're always notified when each and every video tutorial has been uploaded on this YouTube channel. So let's now quickly get into the solving. So we're starting with part A. Part A states that the equation of a curve is y is equal to 2x cubed minus 3x squared minus 12x plus 30. We're finding the coordinates of the stationary points. So the equation that we're given, that is the equation, which is y is equal to 2x cubed minus 3x squared minus 12x plus 30, like that. So the way we find the coordinates of the stationary points is that you have to differentiate the equation that we're given. So in such a case, we're going to differentiate that equation. We're going to consider dy dx. So we're going to consider dy dx since they have mentioned stationary points. So we're going to say dy dx. So the way we differentiate is that we have to get the power. So in such a case, with the first term, we have x power 3. So the power is 3. We are going to multiply 3 with the terms that we have. So it will be 3, open brackets, 2, close brackets, and then we also have x, and then we have power 3. So 3, after you do that, you have to subtract. You have to say 3 minus 1. Again, there you do the same. 2, again, open brackets, 3, close brackets, and then x, again, you have to say 2 minus 1, and then minus, and then 12 again. So 12x, x has the power 1, x has the power 1. So that is the reason why we are multiplying with 1. So it will be 1, open brackets, 12, close brackets, x to the power 1 minus 1, like that, and then plus. So 30, as it stands, 30 in such a case has the variable of x power 0. It has the variable of x power 0. So when you multiply 0 by, it will be 0 open brackets 30 close brackets x to the power 0 minus 1, like that. So it will be dy dx is equal to, so when you consider that one, it will give you the 6x squared, and then that one, it will give you negative 6x, and then that one, it will give you negative 12. And then on the last part, you need to know that it will give you the value of 0, because when you multiply 0 with whatever you are going to have there, it will be 0. It will equal to 0. So in such a case, there is no need of us indicating the 0. So since they have mentioned that stationary points, we're going to replace dy dx with 0. So dy dx, it will be 0. So in such a case, it will be 0 is equal to 6x squared minus 6x minus 12, like that. It will be 6x squared minus 6x minus 12 is equal to 0. And then what we are going to do in such a case is that we are going to make our work easier. We're going to divide each term in that equation by 6. Each term by 6. We're going to divide each term by 6 to simplify the equation. So that is the way it is. So in such a case, when you simplify the equation, it will be x squared minus x minus 2 is equal to 0, like that. And then the next thing that we have to do is that for us to calculate this one, we can use a number of ways to calculate the value of x. But in such a case, we're going to use the factorization method. And if you're using the factorization method, you need to know the product and the sum. So in such a case, the product is the coefficient of x power 2 and multiplied by the coefficient of x power 0. So in such a case, the coefficient of x power 2, it is 1, and then the coefficient of x power 0, it is negative 2. So in such a case, the product is equal to 1 times negative 2, and when you consider the calculations, it will give you the value which is negative 2. So, and then you need to know that the sum, it is the coefficient of x. The coefficient of x in such a case, it is negative 1. So this is the way it is. So what we're going to use to find the values of x is that we're going to get the product, which is negative 2, and it will be at the top, like that. And then you need to consider the factors of negative 2. So the factors of negative 2, we have negative 1, we have negative 2, like that. So after you consider that one, then you can get the number whereby when you multiply the factor by that number, it will give you negative 2. So negative 1 can be multiplied by 2 for us to get negative 2. So negative 1 can be multiplied by 2 so that we get negative 2, and then negative 2 can be multiplied by 1 so that we get negative 2. So in such a case, you need to consider what pair can be gotten so that when you add, it will give you negative 1, and when you multiply, it will give you negative 2. So all of these two pairs, when you multiply them, it will give you negative 2. Now, which pair can be gotten such that when you add them, it can give you negative 1. So when you say negative 1 plus 2, it will give you positive 1. So that 1 cannot be used. But when you consider negative 2 plus 1, it will give you negative 1. So this is the pair that we are looking for. We are looking for negative 2 and 1. So in such a case, we have to write x power 2, and then after you write x power 2, you have to consider the pair that you found. In such a case, we found the pair of negative 2, 1. -2, +1. So in such a case, the first term that we have, which is -2, it will be -2x. We're going to write -2x and then plus. Since we have +1, so that is the reason why we have written a plus, so it will be plus x and then -2 like that. So that is the way we have calculated this one. So in the expression that we had, which is x power 2 minus x minus 2 is equal to 0, negative x has been eliminated. So in such a case, x has been replaced, negative x has been replaced by negative 2x plus 1. So it will be something like this. So the next thing that we are going to do is that we have to factorize. So we're going to factorize the first two terms that we have. So we have x power 2 minus 2x. So the way we're going to factorize it is that we're going to get the one which is common. So the thing that is common, it is x. So in such a case, it will be x, open brackets, x minus 2 like that. So the next thing that we have to do is that we have to factorize the second terms that we have. So we have those terms. So the way we are going to factorize those second two terms is that we're going to consider a 1. It will be outside the brackets, and then inside it will be x minus 2, and that is equal to 0. So you need to keep in mind that which are inside the brackets, they should be similar. So when you consider, we have x minus 2 on the left hand side, and then we also have x minus 2 on the right hand side. So those inside the brackets, they should be similar to each other. So we're going to get those which are outside the brackets. We have positive x and we have positive 1. So we're going to get those and put them in brackets like that. And then we're also going to get x minus 2 and also put them in brackets just as they are, and that is equal to 0. So the next thing that we're going to do is that we're going to solve the values. We're going to find the values of x. So the way we're going to find the values of x is that we're going to say x plus 1 is equal to 0, or x minus 2 is equal to 0, or x minus 2 is equal to 0 like that. So when you do something like that, when you make x the subject, it will be x is equal to -1 or x is equal to +2. So those are the values of x that we have. Those are the values of x. So the next thing that we have to consider is that you have to get the original equation that we are given. So in such a case, the original equation that we have is y is equal to 2x cubed minus 3x squared minus 12x plus 30. So after you get that equation, the next thing that we have to do is that we have to replace wherever there is x with the value of x which you have found. So in such a case, we're going to start with -1. So we're going to replace wherever there is x with -1. So wherever there is x, you have to replace with -1. So after you replace -1, it will give you the value of 37. So in such a case, a -1 has produced 37, meaning that that is a pair. That is the first pair that we have. So those are corresponding to each other. And then or we also have another x coordinate that we have. We also have 2. So wherever there is x, again we're going to replace with +2. We're going to do that, and then we're going to see the answer that we're going to get. So when you consider the calculations, it will give you the value of 10. It will give you the value of 10. So 2 and 10 a pair. So the next thing that we're going to do is that we're going to write what they want us to find. So they wanted us to find the stationary coordinates. So in such a case, we have -1, 37 and 2, 10. So this is how you're supposed to answer. Even say therefore coordinates of the stationary points are -1, 37 and 2, 10. So this is how you're supposed to answer in an exam room. This is how you're supposed to answer in an exam room. I hope you are clear on this one. So we are done with Roman numeral 1. Let's go to Roman numeral 2 now. Let's go to Roman numeral 2. So Roman numeral 2 states that determine the nature of the stationary points. Determine the nature of the stationary points. So how do we determine the nature of the stationary points? So we had that equation, which is y is equal to 2x power 3 minus 3x squared minus 12x plus 30. So the next thing that we have to do is that you have to differentiate this equation. You have to differentiate this equation. Already found the dy dx. So dy dx is equal to 6x squared minus 6x minus 12, like that. The next thing that we have to consider is that we have to differentiate the dy dx again. We have to differentiate what we differentiated again. So it will be d2y dx squared is equal to, so we're going to use the same way as we did earlier. So we're going to differentiate as we did earlier. So the next thing that we are going to do is that we are going to consider the simplification. So when you simplify it, it will be 12x minus 6, like that. So we already found the coordinates of the stationary points in Roman numeral 1. We already found the coordinates of the stationary points in Roman numeral 1. So the coordinates were like -1, 37 and 2, 10. So we're not going to get the y coordinates. The only thing that we're interested in are the x coordinates. So we're going to start with the first one, which is -1. We're going to replace wherever there is in the d2y dx squared, we're going to replace wherever there is x with -1. And then it will be like 12, open brackets, -1, and then close brackets, -6, like that. And then when you consider the calculations, it is equal to -18. So d2y dx squared is equal to -18 at a point which is -1, 37. So d2y dx squared is equal to -18 when it is at -1, 37. So now you need to get this one. You need to know that when d2y dx squared is less than 0, just know that the point is at maximum. Just know that it is at maximum. So let's go to another one now. So let's go to the next point that we have. So we have d2y dx squared is equal to, so we already found the d2y dx squared. So it is 12, it is 12x minus 6. It is 12x minus 6. So wherever there is x, we have to replace with +2, like that. And then d2y dx squared, it will equal to +18 at 2, 10. So when you see that d2y dx squared is greater than 0, just know that the point is at minimum. So when d2y dx squared is greater than 0, just know that it is at minimum. Just know that the point is at minimum. So this is how you easily identify the nature of the stationary point. So you have to represent your answer as therefore it is maximum at -1, 37 and minimum at 2, 10, like that. So this is how you easily score marks in an exam room. This is how you easily score marks. I hope you are clear. If you're having any questions, always feel free to ask in the comment section. Okay, so now let's go to another part of this question, which is part B. Part B states that given that y is equal to x squared e to the negative x, find the gradient of the curve at the point where x is equal to 1. So now, what are we supposed to do in such a case? What are we supposed to do? First thing that we have to do is that we have to consider the equation that we're given. In such a case, we're given the equation which is y is equal to x squared e to the negative x. So what we're going to do is that we're going to write that equation that we're given. So we have the equation as y is equal to x squared e to the negative x. And then after you write the equation, what is the next thing? What is the next thing that you should consider? So again, the question is requesting us to find the gradient of the curve. It is requesting us to find the gradient. So now, if you're only given the equation and you're given a specific coordinate, what are you supposed to do in such a case? If you're given the x coordinate and you're given the equation, so what you have to do is that you're going to consider the gradient function of the equation. So for you to find the gradient function, you need to find the function for dy dx. So you need to find the derivative of that equation. So in such a case, we are going to say we have the equation which is y is equal to x squared e to the negative x. So we have a dot there which is simply representing multiplication. So now when you try to check these two terms, we have the term which is x squared, and we also have a term which is e to the negative x. Both of these terms have a variable which is, both of these terms are carrying a variable which is x. So both of these are carrying a variable which is x. So now if both of these terms are carrying a variable which is x and there is a multiplication between these two terms, what are you supposed to do? If you notice this, it means that this is the product rule. You have to consider the product rule. That's what you have to do. You have to consider the product rule. And then what are we going to do after you consider this one as the product rule? So what we're going to do is that we're going to say let x squared. In such a case, we're going to consider the first one. So we're going to say let x squared be f. And then we're going to say let e to the negative x be g. So we're going to say let x squared be f, and then let e to the negative x be g. And then after you say this, what is the next thing that you should consider? So you need to consider the product rule. So the product rule is going to be like f prime g plus g prime f, like that. So now what do these mean? So we have expression, we have the expression which is f prime, and we also have the expression which is g prime. What do these mean? What do they mean when we say f prime or g prime? What do these mean? So when we say f prime or g prime, just know that they are talking about the derivative of that expression. They want to know that you need to differentiate that expression. So when they say f prime, it means that you have to differentiate the expression for f. In such a case, the expression for f, it is x squared. And then when we say g prime, it means that we have to differentiate the expression for g. In such a case, the expression for g, it is e to the negative x. So that is what we are supposed to do. So That is what we mean when we say f prime or g prime. It simply means differentiation. It is d dx. So we are going to start with the first expression that we have. We have f prime. F prime, so the expression for f, it is x squared. Now when you check the f has a symbol which is prime. So in calculus, when you see this symbol which is the prime symbol, which looks something like an apostrophe, it simply means that you need to differentiate. So in such a case, we have to differentiate the expression for f. The expression for f, we have it as x squared, so we have to differentiate x squared. And the way we differentiate, we said that the way we differentiate according to the previous tutorials, the way we differentiate, we have to first multiply the power. In such a case, we have to multiply the power which the x is holding, or which the variable is holding. In such a case, the variable is holding the power of 2, and then 2 is going to be multiplied by the base terms. In such a case, we have x. So after you do this, the next thing that you have to do is that you have to subtract a 1 from the power. It will be minus 1, like that. So the overall of f prime is going to be 2x to the power 2 minus 1. And then what about the g? When you check the expression, g is not having the prime symbol. It is not having the prime symbol. So it simply means that we have to get the expression just as it is appearing. In such a case, we're going to get e to the negative x. So that is what we're going to do. And then what is the next thing? So we also have a plus. The plus is going to maintain like that. It is going to be maintained like that. So we're going to write plus. And then the next thing that we're going to do is that we're going to consider g prime. When you check g, the g has prime. It means that we need to differentiate the expression for g. We have to differentiate the expression for g. In such a case, we have the expression for g as e to the negative x. So we have to differentiate e to the negative x. Now, how do we differentiate expressions which have the e function? How do we differentiate that? So the way we differentiate expressions which have the e function is that we have to say d dx is equal to u prime and then e to the u. That is what we have to consider. So in such a case, we're going to say u prime e to the u. And then in such a case, what is u? What is u? So u, it is the power which the e is holding. In such a case, e is holding the power of negative x. So that is what we mean when we say u. We denoted negative x as u. So in such a case, when you check the first expression, it has u prime. It is like u prime. So what do they mean when they say u prime? It means that you have to differentiate the power which the e is holding. So u prime, it is simply telling you that you need to differentiate negative x. So the way we differentiate we said that we have to consider the power. So in such a case, we are considering the term which is negative x. So negative x has the power of 1. So that one is going to be multiplied with the base term. In such a case, the base term, it is negative x. So when you try to differentiate negative x, it will give you the term which is negative 1 x to the power 1 minus 1. That is what you're going to be given if you differentiate that expression which is negative x. So again, we have, since we said that it is u prime multiplied by e to the u. So we're going to maintain the e. We're going to get that e. That is where the e is coming from. And then we also have u. In such a case, the u, we say that it is the power which the e is holding. In such a case, it is negative x. So the power is going to be maintained like that. That is how we differentiate the expressions which have the e functions. So that is the expression for g prime. Now let's go to another one, which is f. So when you check the f has no prime symbol. So what we're going to simply do is that we're going to simply get that expression for f. We don't have to do anything with that expression simply because there is no prime symbol. So we're going to simply get x squared. So that is the expression for g prime. It is -1 x to the power 1 minus 1 and then e to the negative x, like that. And then we also have another one, which is the expression for f. So it is x squared. And then we also have another expression for f prime, which is 2x to the power 2 minus 1. And so we also have another expression for g, which is e to the negative x. So we have found the overall expression for f prime g plus g prime f. So this is how we differentiate. And then the next thing that we're going to do is that we're going to consider the calculations and the simplification. So the first part, when you try to simplify 2x to the power 2 minus 1, it will give you 2x. Simply because when you say 2 minus 1, it will give you 1, and x to the power 1, it will give you x. So we're going to remain with 2x. And then we also have another expression, which is for g prime. In such a case, it is e to the negative x. So again, what we're going to do is that we're going to consider what is in the other bracket. So we're going to write plus open brackets. So we're going to simplify what is in those brackets. And when you try to simplify, it will give you, so the first part, when you try to say -1 x to the power 1 minus 1. So 1 minus 1, it will simply give you the value, which is 0, and x to the power 0, it is 1, and 1 times -1, it will give you -1. So we're simply not going to write -1, so we're simply going to write a negative there. So negative times x squared, it will give you -x squared. So we're talking about that x, which is on the right hand side, which is the expression f. And then the next thing that we're going to do is that we're going to write the expression, which is e to the negative x, like that. So this is how you simplify this one. So it is going to be something like that. So again, there, positive times negative, it will give you negative. So that is where the negative is coming from. So it will be something like that after you try to multiply. So dy dx is equal to, so this is the expression for dy dx. This is the expression that we have for dy dx. So these two are simply not like terms. So what we can do is that we can just further check what we're given. We're going to check what we're given. So we are told that we need to find the gradient of the curve at the point where x is equal to 1. At a point where x is equal to 1. So when you find the expression for dy dx, you're going to get that point, which is for the x coordinate, and then you have to replace wherever there is x with the value that you're given. In such a case, we're given +1, so we have to replace wherever there is x in that expression for dy dx, simply because we said that if you want to find the gradient and then you are given the equation, you simply need to find the dy dx. You need to find the expression for dy dx. So this is the expression for dy dx, and then after you find the expression for dy dx, you need to consider the point, the x coordinate that you are given. In such a case, we're given the x coordinate as 1, so we're going to replace wherever there is x with 1. We're going to replace wherever there is x with 1 in that equation, in that expression for dy dx. So after you replace wherever there is x with +1 with the x coordinate, that is what you're going to be given. So the next thing that you have to do is that you have to consider the simplification. In such a case, we have 2 open brackets, 1 closed brackets, and then we have e to the negative open brackets 1 close brackets, like that. And then we're going to consider the subtraction, and then we're going to have open brackets 1 close brackets squared e to the -1, like that. So we're going to do the simplification. So the first part, it will give you 2e to the negative 1 when you try to simplify that one. And then we have the second part, which is that one, it will give you e to the negative 1. So when you try to look at these two, which 2e to the negative 1 and negative 1e to the negative 1. So these two, when you look at them, they are like terms. These two are like terms. They have one thing in common. They both have e to the negative 1, meaning that these two can be easily added or subtracted. So this can be added or subtracted. These two are like terms. So in such a case, we're going to simply say 2 minus 1, it will give you the value which is 1. So dy dx is equal to 1, and then we are going to maintain that one, which is e to the negative 1. It is going to be like that. So in such a case, the overall is going to be like dy dx is equal to 1 e to the negative 1. So this is what we're going to simply do. So we said earlier that the dy dx of a certain point, particularly if you're given the x coordinate, it is the one that is going to give us the gradient. It is going to give us the gradient. It is going to help us to find the gradient. So in such a case, we can conclude that our gradient, it is 1e to the negative 1. But in such a case, we are simply going to remove the 1 simply because even if we don't write it, it is going to be seen as the same. So in such a case, we're going to write e to the negative 1 like that. So if you want, you can further simplify this one. You can further do calculations on this one, and then you're going to get a number which is you're going to get an answer which is going to give you the numerical value. So in such a case, it is going to be something like that. But in this tutorial, we're going to get this one, which is e to the negative 1, so that our answer has accuracy. Because when you try to consider 0.367879441 like that, you have to round off this one. In such a case, you're not going to get the answer which is as much as accurate as that one, which is e to the negative 1. So in such a case, we're going to simply get e to the negative 1. So now I hope you have understood the concepts behind the e functions, and I hope you haven't forgotten to subscribe to this YouTube channel, and I hope you haven't forgotten to share, to like, and to also comment. Thank you for watching. See you to another video tutorial.